trying to get. So my missing angle is going to be 116.
Or you could have just taken with 150 minus 34 would give you the same thing. Right?
Mm-mm. You just got lucky. We're doing lucky math.
Okay.
Yeah, you got lucky, but it worked, but you got lucky. Now, this is probably going to be the hardest one of these that you're going to do. Here is X. You come from both sides to get to X. We're going to jump into this triangle by using what rules? The supplementary. It makes a straight line, so those two have to add up to 180. So we're going to jump into this triangle. But y'all, this triangle, you have that angle, but you don't have this angle. So you can't get that one because you have to have both of these to get that one. So we jumped into here, but we can't go any further this way. So then you've got to come over here. You have this angle, and we need to jump into the triangle. What do we know about these two angles?
They're equal.
They're equal, because if I folded my paper right here, those would be like butterfly wings. So if this is 38, that's 38. So then we have this triangle. We know this angle and this angle, so we can find this one because they add up to 180. Once we know this one, what do we know about these two angles? They make a straight line. So we can get this one. Well, now we know these two angles, and we can get that one. So we have to...
That's a lot.
It is a lot. So here, problem number 1.
It's going to be 68.
So if this is 112, we can find this angle by doing 180 minus 112 because they make a straight line. What is it?
68.
68. So this one's going to be 68. I can't go any further that way. So problem number 2 is to realize that this angle and this angle are the same because I needed to jump into that triangle. Problem number 3, so this was problem number 2. Problem number 3 is to see this triangle. And in that triangle, I have a 30 and I have a 38, and I'm searching for this angle. So that's going to be 180 minus 30 minus 38, which gives me 112. Then I'm going to come here to problem number 4. That gives me a 112. So 180 minus the 112 gives me a 68. 68. So 68 is here. So problem number 5 is going to be here, which gives me a 68 here, a 68 here, and an X there. So it's going to be 180 minus 68 minus 68 is?
44.
There's your final answer.
I get it now, but at the beginning.
Yeah. The more of these you do, the easier they are. All right. Interpreting Venn diagrams. Poor Valencia was ready for them to get her. This is your basketball players. Those are all your basketball players. This is all your softball players. Notice how you have 2 players that are green. They play both basketball and softball. Okay? So how many people play basketball? Basketball is going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Y'all with me? How many people play both? 2. How many people play softball but not basketball?
6.
So a Venn diagram, which is what this is when you have an overlap. They want you to realize that these people play just basketball. These people play just softball. These people play both basketball and softball. All right, parallelograms. We've done triangles. Triangles were 3 sides. These are called quadrilaterals. 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 These have 4 sides. Quadrilaterals. Looks like if you have quadruplets, that's 4 babies. Quadrilaterals is 4 sides. Now, a parallelogram is a squished rectangle. So if you take a rectangle and you sit on it, a rectangle that you sit on. So we should all know what a rectangle is. A rectangle is when the top and the bottom are equal, and the left and the right are equal, and it has right angles. That's a rectangle. A rectangle is when the top and the bottom are equal, the left and the right are equal, and we have right angles. That's a rectangle. A parallelogram, the top and the bottom are equal, the left and the right are equal, but you don't have right angles. You set on a box. So this is still equal to this, and this is still equal to this, but you set on it. So it's like a leaning box. That's a parallelogram. A square is when all sides are equal and you have right angles. That's a square. A rhombus is a squished square. So 5, 5, 5, and 5. You set on a square. A rhombus is also called like a baseball diamond. So if I take a baseball diamond, so basically the only difference between a rectangle and a square and a rhombus and a parallelogram is you squished them. They're no longer right angles. It's damaged goods. So if I come down here, that rhombus is a squished square. So if I take my square and I squish it, 5, 5, 5, and 5, does it have 2 pairs of parallel sides? Is the top and bottom parallel? Is the left and right parallel? So does it have 2 pairs of parallel sides?
Yes.
So if it has 2 pairs of parallel sides, can it have 1 pair of parallel sides? No. Now, congruent, y'all, congruent is a fancy name for equal. Are all sides equal?
Yes.
Yeah.
5, 5, 5, 5.
5, 5, 5, 5. Does it have 4 right angles? No, because it's squished. A square, 5, 5, 5, 5, with right angles. Does it have 2 pairs of parallel sides? Yes. This is parallel with this is parallel with this. So if it has 2 pairs of parallel sides, can it have 1 pair of parallel sides? Does it have all congruent sides?
Yes.
Congruent means equal. Does it have 4 right angles?
Yes.
A parallelogram, that is a squished rectangle. So this is this. So this was 4, 4, 5, 5. Does it have 2 pairs of parallel sides? Him and him, are they parallel?
Yes.
Him and him, are they parallel?
Yes.
So yes, it has 2 pairs of parallel sides. 1 pair of parallel sides?
No.
No. Congruent sides?
No.
No, because top and bottom are congruent, left and right are congruent, but they're not all 4 congruent. All 4 right angles? No, because it's squished. It's squished. We set on it. Lindsay, if you set on it, it's probably still have right angles. If I set on it, it ain't going to have no right angles. We good? Now, area. Let me go into a better area problem. That one's too easy. They want us to distinguish the difference between area and perimeter. Area is when you're doing the inside of something. Perimeter is when you're doing around or the outside of something. So in your backyard, if you're doing the fence, that's going to be the perimeter. If you're doing the grass, that's going to be the area. So the inside is the area. The fence is going to be the perimeter. Okay? Area, the units are square, inches squared, feet squared, yards squared. Perimeter is inches, feet, yards. Perimeter has plane units. P for perimeter, P for plane. Now, when you're doing perimeter, you're going to add up all the sides. When you're doing area, you're going to do length times width. Now, for this problem, sometimes they'll ask area first and sometimes they'll ask perimeter first. So they may do area then perimeter, and then they may do perimeter then area. So for area, we're going to do length times width. For perimeter, we're going to add them up. So if this is a rectangle, that means the top and the bottom are the same. That means the left and the right are the same. So for my area, we're going to do length times width. For my perimeter, we're going to do top plus bottom plus left plus right. My perimeter is going to have plane units. My area is going to have squared units. This is my area, this is my perimeter. Now, if we're replacing the glass, if somebody shattered the glass in this window and we're replacing that, is that area or perimeter?
Area.
That's the area, that's the inside. So my first one says if you are replacing the glass, that's going to be the inside, so that's the area. If you are replacing the wire around the window, that's going to be the perimeter. And y'all, even the word perimeter has the word rim in it. The rim, like the basketball goal. The rim. Around. Very good. Okay. For these, there's two different ways you can do these. It totally does not matter to me. I have some people that see one way and some people that see another way. Now, I have some people that will take this shape, and I'm going to do it both ways, because some prefer one way and some prefer another way. Some people want to cut, and they see a house and a chimney. Do y'all see that? And then I have some people that see, I'll come over here and show you. Okay, so the house and the chimney. Do you see that here's the house and here's the chimney? You're going to find the area of the house, the area of the chimney, and you're going to add them together. Because you have two pieces of paper and it's like you're gluing them together, so you add. That's one way to see it. Then other people, do you see that this is a whole sheet of paper? So you would find the area of the whole sheet of paper. Then you would find the area of the little red. So the whole sheet of paper minus this, because we're taking it away. So you can either do it as two individual pieces and add them together because you're gluing it, or you can fill it in and do a whole sheet of paper minus. Some people prefer one, some people prefer the other. Does not matter. But you need to understand, is it a subtraction problem or is it an addition problem? So if you're gluing it, it's an addition. If you're taking it away, it's a subtraction. So, let's start off with the one on the left. It doesn't matter to me. if I do this, this is a rectangle, so I'm going to do length and width. What is the length and width of the chimney? What numbers am I, when I do that, what numbers am I tracing? 3 and 3. You with me? 3 times 3 is 9. The 5, let me hold this back up. The 5 is from here to here. The 5 is the whole house and chimney together. The 3 is just from here to here. The 5 is from here to here. See the difference? Okay. Now, so 9 is just this piece. Now I need to know the width and height of here. So how long is this and how tall is this? Perfect. It is 6 wide because 3 only goes from here to here. 6 is the total width. We can't use 5 because 5 is from here to here. If this is 3, and the whole, so if this piece is 3, this is 3, and the whole thing is 5, then this has to be 2. So we just said that the whole thing is 5, and this piece is 3, which means this piece has to be 2. So it is a 2 by 6. So 2 times 6 is 12. So we have 9 from the chimney plus 12 from the house is 21. That's gluing it. Now let's do it the other way. Let's treat it as a whole sticky note. Let's fill it in. What is the total height and total width of that whole sheet of paper? The whole height and the whole width. 6 times 5. 6 times 5. So the big rectangle is 6 by 5, which is 30. What is the width and height of the piece of paper I'm tearing out? What's the little rectangle? 3 by 3. 3 by 3. 3 by 3. And I'm subtracting this time because I have a sticky note minus the corner. What does that give me? Same answer. Doesn't matter. Whichever way. It's like when you look into clouds. Some people see an elephant and some people see a rat. They're the same. I mean, it's the same. All right, look at this one. Do you see a house with 2 chimneys? Or do you see a piece of paper with a piece cut out? It's just according to how you want to look at it. To me, what I see a piece of paper with a piece cut out. You may say, I see a house with 2 chimneys. So you would have to do the length and width of this, the length and width of this, the length and width of this, and add them up. I'm going to do the overall length and width, and subtract. So tell me, what is the length and width of the entire thing? What's the length and width of the entire thing? How tall and how wide is the entire thing? 11 by 5. 11 by 5. 55. What is the length and the width of the piece that I'm tearing out? 3 by 4 is this way. 3 by 3. 3 by 3 is what I'm tearing out, which is,
9.
am I adding or subtracting?
Subtract.
Subtracting. What is 55 minus 9?
Would it be 41 to 1?
Well,
No, 41.
There we are. That's my answer. So Alex may explain it as adding, and I explained it as subtracting, but we're going to get the same answer. Does that make more sense? All right, when we come back next time, we're going to be doing triangles. Look, same thing. We're doing those next time. Get out there and start working, y'all. 75% next week.
That was cool.
I do.